So inverse trigonometric graphs are also very straightforward graphs. So you have 6 inverse trigonometric functions. Y is equal to sine inverse x, y is equal to cos inverse x. So let me first draw these two graphs. So for y is equal to sine inverse x, the domain is minus 1 to 1 and the range is minus pi by 2 to pi by 2. For cos inverse x, the domain is minus 1 to 1 and the range is 0 to pi. So if you draw the graph of sine inverse x, if you want to draw the graph of sine inverse x, in terms of x, the graph lies between minus 1 and plus 1. In terms of y, the graph lies between pi by 2 and minus pi by 2. So the graph, I can say that it lies in a box which looks like this. The graph completely lies inside this box between minus 1 and plus 1, between minus pi by 2 and plus pi by 2. And for positive values of x, the answers lies in the first quadrant. Sine inverse of positive numbers gives you angles between 0 and pi by 2. Sine inverse of negative numbers gives angles between 0 and minus pi by 2. So you get the graph in this box and this box. So how does the graph look like? It is the inverse of sine. So it looks something like this. At x is equal to 1, sine inverse of 1 is pi by 2, sine inverse of 0 is 0, sine inverse of minus 1 is minus pi by 2. So you get graph which looks like this. And if you take y is equal to cos inverse x, here also the domain is minus 1 to 1, but the range is 0 to pi. This time the range is not going to the negative values. Means the graph completely lies this time in this box. Graph completely lies in this box. And when x is positive, that is cos inverse of a positive number gives you angles in the first quadrant. Cos inverse of negative numbers gives you angles in the second quadrant. Cos inverse of 1 is 0. Cos inverse of 0 is pi by 2. Cos inverse of minus 1 is pi. So how does the graph of this look like? It looks something like this. The graph is as simple as this. So cos inverse x graph lies completely above x-axis and it is a decreasing graph, you see. Cos inverse x is a decreasing function and sine inverse x is an increasing function. So you just have to go up as you go right for sine inverse x. You just have to go down as you go right for cos inverse x. Next, if you take the graphs of y is equal to tan inverse x and y is equal to cot inverse of x. So if you take the graph of y is equal to tan inverse x, the graph looks something like this. So first, analyze what is the domain and range of tan inverse x. The domain of tan inverse x is all real numbers and the range is open minus pi by 2 to plus pi by 2. That means the domain is all real numbers, that is the graph covers the complete interval on x-axis, but along y-axis it covers only between minus pi by 2 and plus pi by 2. And the range is open minus pi by 2 to plus pi by 2. That means the graph never cuts the line y is equal to plus pi by 2 and minus pi by 2. The graph never cuts this line. It goes closer and closer to pi by 2, closer and closer to minus pi by 2. And if you take positive values for x, you get answers in the first quadrant, means you get graph here. And if you take negative values of x, the graph is in the answers are in the fourth quadrant. That is, you have a graph in this part and this part. And tan inverse of 0 is 0. It has to asymptotically touch y is equal to pi by 2. So the graph looks like this. It also has to asymptotically touch y is equal to minus pi by 2. It has to go like this. So this is how the graph of y is equal to tan inverse x look like. Y is equal to tan inverse x looks like this. Now how does the graph of cot inverse x look like? It looks similar, but this time the domain is minus infinity to plus infinity, but the range is open 0 to pi this time. The range is 0 to pi, means the graph covers the region of y between 0 and pi, and the range is open 0 to pi. Hence this line will be an asymptote, this line will also be an asymptote. And if positive values goes inside cot inverse, you get angles in the first quadrant. Corresponding to x positive, you get values in the first quadrant. Corresponding to x negative, you get values in the second quadrant. And cot inverse x is a decreasing function. It has to be asymptotes here. It has to lie in these two parts, and cot inverse of 0 is pi by 2, so it passes through this point. So the graph is a decreasing graph which looks like this. Y is equal to pi and y is equal to 0 are asymptotes. It passes through 0 comma pi by 2. It's a decreasing graph. The domain is minus infinity to plus infinity and the range is 0 to pi. So these are the graphs of tan inverse x and cot inverse x. And finally, you have the graphs of y is equal to cosecant inverse x and y is equal to secant inverse x. So what is the domain of cosecant inverse x? Minus infinity to minus 1 union 1 to infinity. And what is the range of cosecant inverse x? Minus pi by 2 to pi by 2 excluding 0. This is the domain, this is the range. And correspond to secant inverse x, the domain is minus infinity to minus 1 union 1 to infinity. And the range is close at 0 to pi except pi by 2. So you have this as the domain and range for cosecant inverse x and this as domain and range of secant inverse x. So if you draw the graph of cosecant inverse x, the range that needs to be covered is minus pi by 2 to pi by 2. And the domain that needs to get covered is 1 to infinity this side and minus 1 to minus infinity this side. That is, the graph lies on this side of x-axis, on this side of x-axis. And in terms of y, it covers this range. And you don't have a 0 here in the range. So that means the curves are asymptotically touching the x-axis. Now if you get positive numbers inside cosecant inverse, if positive numbers go inside cosecant inverse, you get angles in the first quadrant. You get angles in the first quadrant, you get some graph here. And combining all that we have told, cosecant inverse of 1 is pi by 2. And we have seen that it has to asymptotically touch x-axis. So it has to go like this. That's how the graph looks like. And cosecant inverse of minus 1 is minus pi by 2. It has to touch x-axis asymptotically. Hence the graph looks like this. As simple as this. Next, if you want to draw the graph of y is equal to secant inverse x. Again, the range is from 0 to pi except pi by 2. So this time the range that is being covered is 0 to pi except pi by 2, that is you draw a horizontal line y is equal to pi by 2 and the graph asymptotically touches this line because this is not present in the range. Now the domain is 1 to infinity and minus 1 to minus infinity. That means the graph lies on this side of x-axis and this side of x-axis. And if a positive number goes inside secant inverse, the answers are in the first quadrant. Secant inverse of 1 is equal to 0. It starts from here. It has to asymptotically touch this line. So it has to go like this. It has to go like this. Similarly, if you go with the negative numbers, if I put negative numbers in the place of x, so you get angles in the second quadrant. Secant inverse of minus 1 is pi. Secant inverse of minus 1 is pi. And it has to asymptotically touch this line. And the graph looks like this. The graph looks like this. So this is the graph of secant inverses. So I hope you understand these graphs. Again, these graphs should be at the tips of your fingers. It's not like you think and draw these graphs. So whenever you have secant inverse x, you have to draw this graph very quickly. Then you will be able to draw complicated graphs in decent amount of time.